This is question number 27, part A, on page 150, unrelated rates. It says that this part of the ladder is moving out at 2 feet per second, so this part here is sliding down. Part A is asking how fast the top of the ladder is moving down the wall when the base of the ladder is 7 feet from the wall. So as this slides out, this side here increases in length. So I am going to call that side X. As this moves down, this side here decreases in length. We need to call it a variable. I'm going to call that Y. Looks like they might have called it R. We're going to leave it as Y, it's fine. And then this side here, as this slides out and this slides down, the length of the ladder stays the same. So we can leave it as 25. We don't need to call it a variable because it does not change. We need to set up a relationship between our variables. That relationship is the Pythagorean theorem, x squared plus y squared equals 25. And then find the derivative, 2x times dx dt plus 2y times dy dt is equal to the derivative of 25, which is 0. We are asked how fast is the top moving down the wall when the base of the ladder is 7 feet from the wall. So if the base of the ladder is 7 feet from the wall, that's telling us x is 7. We also know that dx dt is the rate at which x is changing. X is getting bigger by 2 feet per second. They don't tell us what y is. In order to get y, we need to plug in 7 for x. And now take a look at our right triangle. Basically, you're going to this formula here and putting 7 in for your x. And that should be squared. So if 7 goes in for x, x squared, 7 squared, plus y squared equals 25 squared. I think that's 625. So we have 25 squared, which is 625, minus the 49. Y squared is 576, and then take the square root. So when x is 7, our y value is 24. That goes in for y. And we're looking for the rate at which this is sliding down. We're looking for dy dt. That's our variable we want to find. And we get negative 0.583. Negative because side dy dt is decreasing in length. 0.583, the units for distance in this problem is feet, and the distance for time in the problem is seconds. So side y is decreasing at a rate of 0.583 feet per second. It's asking how fast. You would probably just report the positive value, although that's not a big deal. 0.583 feet per second. It goes on to ask how fast is it moving when this is 15 feet from the wall. So you would plug in 15 here, plug in 15 for x, and solve for y, and then you'll get a different value. And then do the same thing with 24. That is part A from